I have a question for Omar. I was wondering about the potential geographic, what geographic kind of focal area your model would apply to, whether it would have any applicability to wetlands like in South America or Mediterranean climates where the plant species were succulents or had different growth forms.
Thank you for the question. What I was not able to show you today is the framework of model development. The framework is robust. It can be applied anywhere in the world. Now, the exact coefficient that I showed you for the Euclid Bay system, they may or may not apply. It depends on the actual data and fitting. But as you saw, that we have identified the major drivers, such as we know that mechanistically light, temperature, salinity, they are expected to be the drivers of and water depth, drivers of greenhouse gas fluxes such as carbon dioxide and methane. So from that conceptual perspective, yes, it is applicable. Now the exact model coefficients, they may or may not apply. So it depends on what kind of wetland regime, based on vegetation, climate, we would be applying the model to. In summary, yes, the modeling framework is robust and generic. It can be applied anywhere in the world.
Thanks. Yeah, I just had a question either in modeling or measuring the carbon fluxes. If you thought about the soil types that you're on, like if it's all organic matter, if it's all peat, or if you're shallow to the sand layer or anything like that.
Is it for me?
It could be either in modeling or in those of you who are measuring actual carbon fluxes on the marshes.
Yes, for the soil, I think the soil is one of the major driver of the supporting the coastal salt marsh system. In our project, we basically consider the nitrogen, change of nitrogen loading and vegetation zone, but the soil in those areas basically similar. But if we move to other places, I think the soil condition will influence of the, maybe not species, but at least the density and support the leaf area of the salt marsh. I think that eventually will change the carbon uptake rate or carbon sequestration rate of the system, giving other conditions similar. I think, yes, soil condition will be an important factor.
Just to add, Omar, did you want to say anything before I say something, or are you good?
No, go ahead.
Okay. When we think about different types of projects or different types of land management, whether you think about an organic soil, a soil with an organic fabric, or a mineral soil, feeds in a number of ways. Interestingly, though, the carbon density is about the same between the two, give or take. But if you have an organic soil, the Sacramento Delta is kind of the poster child, and you continue to drain it, you can get a deep hole in the ground, and you can continue to release that CO2 until the entire stock is gone, depending on your land management. So either till the stock's gone, or your management process changes. So that feeds into your baseline assessment about how you think about this. On a mineral soil, just like further down in San Francisco Bay, then you could drain the soil and then it will eventually stop. The emissions will stop at a certain depth. Even though you've got mineral organic soils underneath, they won't be reached by the activity. And so you have a finite peat depletion time, if you want to call it that, in which the emissions take place. So you have to recognize that as part of your accounting. So your type of soil and your management approach factors into that. And then on the other side of it, when you think about the permanence aspect and how resilient the system is going to be to sea level rise, then the more mineral soils are more likely going to be more resilient to sea level rise because of the supply of mineral sediments. And so you have to factor that in a way into your projection of how the system is going to respond to sea level rise as well. So it feeds in different parts of the planning process, but it's important to know. One of the things that'd be helpful to do, I think, is there are maps of histosols for the US. They probably are where most of the emissions are taking place on former coastal wetlands, but all of that's yet to be quantified. And I think some work there that'd be really helpful is quantifying the emissions on these histosols and coastal lowlands around the US.
I just want to add one more thing. When we talk about soil in a coastal wetland, actually it's the only place for store carbon, because when we talk above ground, it's just growing and gone basically every year, the cycle every year. But all the carbon actually stored in the soil, in the sediment, in the coastal wetland. So when we talk about carbon, actually it's stored in the below ground. So everything is below ground. That's why in a coastal wetland, the soil is accumulated over the years. So it's different from the other terrestrial upland system, which the accumulation of soil is very, very slow, even can be saturated. But in a coastal system, yes, the soil and sediment is accumulated carbon. It's a pool that stores carbon. It of course supports the plant, but also it basically it's host all the carbon there.
Okay, I'll ask my question. It's I thought it was really instructive to see an example of a project. So Tom's presentation, it linked really well with both Steve and Steve's talk. And so my questions had to do with trying to put this together. So two things I noticed in Tom's talk that I thought were really interesting. One was every 10 years you had to redo the baseline. And I'm curious, if the baseline is changing, does that change your crediting? Or do you just do it for as an accounting effort? And then the second was, there was a big loss of forest and shrub and so on into salt marsh, and there's obviously the people maybe didn't like that so much, but there was also just that stock loss of the trees and so on. I just kind of did back of the envelope just to get a sense, and it was significant, and I just was curious, is that a part of the analysis, because it kind of fits with what Steve was saying, no unintended consequences or no adverse, there was part of, you were saying one of the things you have to deal with is no, what's it? No leakage or collateral damage or whatever the word you used was.
You want to start? You want me to? Okay. And do the first part of your question again real quick. Thank you. Okay. So, right. So you do have to reassess the baseline every 10 years, and it does change your crediting going forward from that point. So if the baseline changes, and the baseline is, again, what would happen in that landscape if you didn't do your activity. It's kind of guesswork, right? So it's a lot of modeling, a lot of guessing, and pretty much you have to justify it. But yeah, you would have to readjust. Going forward, your crediting would be based on the new baseline.
Yeah.
Right. So sea level rise could be higher than anticipated, or your. I mean, one baseline condition wouldn't be that your bridge and your limited culvert just collapsed, right? That's not going to be a likely baseline scenario. It's a possible future scenario, and now you just have natural tidal exchange again, right? Maybe a desirable one, I don't know. But yeah, so if sea level, like maybe in a different site than Herring River, sea level rise, if you can't control it the way that they can, if it's faster than you think, that could impact your baseline. Maybe we know more about what happens to drowned carbon in 10 years than we know now. Right, that could impact it positively or negatively. What was the second part of the question? Trees. Oh yeah, and you asked about trees. Thank you. I can't keep the thoughts in my head right now, apparently. So if you drown those trees and those are allowed to decompose, that would be an emission that you would have. The shrubs and the trees in the landscape now at Herring River, that would be an emission that you'd have to account for. But there may be a use of those wood products that would not create an emission, or that you might even get a credit for. So, and I don't know enough about those options. Maybe somebody else does.
Well, I would just add to that to say it's kind of one of those emerging things we're starting to think about, and I would encourage anybody thinking about this would be helpful. Is it's the same with sea level rise. We're going to displace lowland forest with coastal wetlands, coastal marshes. It'll be the same in certain mangrove systems. Certain mangroves will drown out because they can't keep up with sea level rise. So what do we do with those woods? Do we just allow them to drown and stay in place? Or do we harvest them and try and do something else with them? It hasn't really been thought through yet. But that's going to be something we're going to have to get into. I think as we think a bit about the landscape. But absolutely, you've got to factor that into your project accounting as well. You know, all emissions and reductions have to be figured in, not just the ones you like.
Thanks. Yeah, you're right. There's the carbon that's in the existing biomass, and as a simplification in what Tom is doing so far, we just said, well, we're not sure. It's pretty clear we're going to lose that woody biomass, but we're not sure what's going to happen with soil carbon because that soil's been either drained or flooded for about 100 years. There's been degradation. There have been other changes. When we reintroduce salt water and then we reestablish a salt marsh, we'll start to, we don't know what the effect of the added salt water will be, but we do know if we successfully produce a salt marsh, that we'll have added sequestration, which then offsets some of the carbon loss from the biomass. So although the methane concept was the newer idea, it's actually simpler and we know more about it than we do about what's actually going to happen with the carbon stocks. So we hope to get some new information from a new project that's just spinning up, which you're aware of, to see what those changes in carbon stocks might be as well.
And one more thing, I think it would be very interesting compare with the forest or grassland with salt marsh. I think that both systems are taking up carbon, through GPP, through photosynthesis. For the forest or upland system, the decomposition rate is higher. But in the salt marsh, the decomposition rate is very low because of the suppress of the water and also the salt and the anaerobic condition over there. So basically, you can imagine the two systems. One system, forest or grassland upland system, they are taking up carbon, they are releasing carbon at the meanwhile. So basically in and out. And the other system, coastal wetland, is in, but not much carbon out. So that residual become higher and higher. I think that is the main kind of difference between those two systems.
I just wanted to add one other thing on the baseline question, because I think that's a tricky one, and in a way it creates risk for anybody trying to sell carbon credits. And I think, as the methodology, I assume it will evolve over time as, practical considerations get factored in. But the idea, for example, that a regulatory change 20 years from now could make all your credits go away strikes me as sort of problematic. I mean, if you went into this with, the intention to restore your wetland and get the credits and, you had no way of predicting, a future change like that, I think it creates a lot of risk, and maybe there should be some consideration of the types of baseline issues that, kind of change your credits and the types that you're grandfathered from.
And just to add to that, it's a great point. Carbon markets are pretty young, and most projects haven't been around 10 years yet. So to say that they have to reassess the baseline in 10 years, a lot of projects haven't been through that step yet, probably particularly in the land use sector. I think that there will be a lot learned and potentially a lot of changes by the time that any of our projects have to reassess their baseline. So.
I had a question about the lateral fluxes for Kevin. I was wondering if you noticed any patterns with tides and light. For instance, I would imagine that the lateral fluxes with a high tide at night might be different than the lateral fluxes with a high tide during the day. So I was wondering if you could comment on the interaction of tides and light with the lateral fluxes.
Yeah, it's a good question because a lot of the fluxes that we're seeing are probably related to current activities of the plants themselves. And so whether they're photosynthesizing or respiring could alter the fluxes at that moment. With the new data that we have, some of the data that I showed today with the continuous flux estimates over extended time, we just generated those very recently. And so I haven't yet analyzed day-night cycles and that kind of thing. We do have very clear differences with spring neap cycles for sure. But it's a good question yet to be answered on the sunlight.
Any other hands? I'm gonna put on my.
So Bob Chen, UMass Boston. You've had 5 years working in the science and talking to stakeholders, and there's been this very rapid increase in the acceptance of blue carbon as a term that you can actually talk about and people might understand. I'm wondering what, like, your biggest success, what is it that allows you to talk to stakeholders in a meaningful way, to engage a stakeholder and say, oh, blue carbon, that's something I should think about, a project there. And then what is your major hurdle about what is it that you need to convince? Is it methane? Is it the term blue carbon? Is it the dollars, that is the success? And then what is the biggest barrier?
Maybe we should do this, each one of us. It's a good question. You want to start, Steve?
Oh, thanks, yeah. Wow. Very success. No, it's you're getting your money's worth. We hope, maybe not. I can dive in. So I think the biggest, the door is well, there's two things I think that open the door on this conversation with stakeholders. One is climate change, and that may or may not be a door opener for some stakeholders, right? So, and the other land use folks have paved the way, right? So forestry has been out front on this, and people think of carbon offsets to go plant a tree. Right, and so we have something to compare ourselves to and something to follow in their footsteps and learn from. So climate change, I think, opens one door, but it doesn't always open the door. And the other is just the ecosystem service values that we've talked about today. Right, so I work for a national nonprofit, and when I'm promoting estuary restoration and conservation, it's all about, and these days it's resiliency, right? So you have to use the R word. In DC anyway, but it's all about fisheries and economic benefits and aesthetic value. I mean, whatever it is that you care about estuaries, everybody has something that they'll connect to there. And so I think the better we get at quantifying that, about describing it, and it's not always about measuring it and quantifying it either, but bean counters like beans.
Allowing a quantification on something that is a non-monetary value to some of them?
Sometimes you can. Well, yeah, so it depends who you're talking to. So, that's part of the problem is, right, you have to have a message for every different audience and something that resonates. So these are some of the things that resonate some of the time. The barrier is tricky. If I just put on the carbon market hat and trying to monetize, right, trying to use the carbon markets to monetize the work we're doing and get paid for it, I'm going to say it's two things. One is the fact that there's really only a voluntary market in the U.S. So there's no driver, and David touched on that this morning, and he was saying you just need to create more demand. I don't know how to create demand. I can have a great product. We have a great product. I don't know how to get people to feel like they need it as opposed to they want it. And secondly would be the price, and we talked about social cost of carbon today. So. And John kindly offered $200 a ton, I think it was John, which we'll accept gladly. Price would help as well. So those would be the two things I would say.
Yeah, I think Steve hit a lot of really good points there. In terms of operationalizing the discussion about blue carbon, we had a remarkable piece of luck at the end of 2010. The IUCN and UNEP brought out 2 reports on blue carbon, so the word was starting to socialize. What we didn't realize, a few of us went to the climate change negotiations in 2010, and we had a simple message: it's the emissions side that's important. And our question was, where was the IPCC? We each asked that in this meeting. And what we didn't know was the IPCC were just about to revise and update their 2006 guidelines for wetlands. And so a month later, we got a phone call saying, what's this coastal wetland stuff? And the IPCC were now interested. So it was a remarkable piece of luck just to ask the question at the right place at the right time. And because the IPCC brought out the guidelines, It means that a lot of countries are now looking at this, that before it was, wetlands destruction was something that just went on and nobody was looking at. And so that was very helpful. I think Steve's point about price and demand is a very good one. If the price was closer to the social cost, we would have a lot more projects. In the Sacramento Delta, which is one of the really big carbon stock, big emissions, it's still 8 times more viable to grow corn than it is to grow carbon in the Sacramento Delta. So we need to fix that equation.
I think after Jim speaks, I will also offer some comments on the stakeholder side on what we learned
Okay.
at the local level. Jim?
For me, I think from this project, the success is that I finally get a very clear message I can deliver to stakeholders is that there is blue carbon there in people's backyard, in the salt marsh, in somewhere near the coast. And we can measure the blue carbon, and we know how much blue carbon is there, basically. It's a clear message. It's not from the book, from somewhere else. It's just people, stakeholders, the land. We can tell them how much carbon is there. We know it is blue carbon from many aspects. We measure the carbon flux. We measure the carbon storage. Basically, we can tell people there's carbon there. So I think that's a really big message for us. For me, I think it's 100% confident to tell people that there's a market there. There's a carbon there. You can bring to market, bring to exchange, or do something. But there is there.
Thanks, Jim. I also wanted to thank you, Bob, for that question, because I think it kind of brings us full circle. In the morning when I gave the overview of the project, I kind of painted the picture of what we meant by collaboration in the context of this project, and that it was really trying to integrate people who we would label as potential end users of this information, and those who have a stake in just wanting to better understand this ecosystem. How do we bring them into the question? And our challenge was, if you could think with us 4 years ago, is that there was really, I painted the context at very low level attention on this and even low understanding. So to me, I think one of the biggest successes is the contribution that this project has made in terms of building awareness and kind of raising attention on this as an important ecosystem service. One little nugget here, I spent a lot of time doing interviews in the first year of our project and having conversations one-on-one with people, because that's the kind of dialogue that we needed to kind of really, we couldn't just pick up the phone and say, hey, do you want to learn something about blue carbon? That just didn't go over. And so you kind of went through like a couple iterations of explaining it before we kind of started getting that conversation going two-way. And we did a survey of conservation agents. How many people in here know who a conservation agent is, or conservation commission? These are folks who work at the local level who are administering the Wetlands Protection Act, so they have a regulatory function and they make permitting decisions about things that happen in our wetlands. And just we interviewed a third of them on Cape Cod. So it's not really a big sample size, but it's a third of the community of conservation agents. And none of them were aware, or really, and it's not that these people don't have science backgrounds necessarily, but in the context of their work, they're not thinking about this element of an important service that the wetlands provide. And I always tell that story because I think that it was very eye-opening for us, even me on the recipient side of just listening to them, wanting to know more about this. And Steve made the point about it's different things to different people. There's no magic kind of message. But I think we do have to hone our message. And for our local stakeholders, grounding this project, we really had to bring the blue carbon and make a marriage with the nitrogen loading aspect of things as an angle for why would we consider nitrogen loading in the context of blue carbon? Why would we pick that up? Because the potential is there for emissions of N2O as another powerful greenhouse gas, but could it be affecting this important service that we're talking about, that the ecosystem provides? Could it be actually limiting the ability of wetlands to do that? And that was an arresting point for our stakeholders, because they could tie it back to all the nitrogen loading and water quality work that they were seeing. And we were conceptualizing that, could it be a kind of double whammy argument? So you're saying we need to clean up nitrogen loading because of all the eutrophication impacts and the degradation that we're seeing on the water quality side. But should it bear out from this study and maybe others that you're also seeing an impact at the wetlands level, then that's something major. So not that they don't have enough impetus on the water quality side, but if you could merge those two worlds and also improve understanding of blue carbon. And I don't want to go on, but we have other story of the kind of things to make that connection. But I think the building awareness, because it was such a low recognition, seems simple, but I think that we've definitely seen dramatic increases in that, and even in the National Estuarine Research Reserve System that we're a part of, spread all over the country. Again, not much emphasis there, but through this project, a ton of work or a ton of interest has opened up on that front in terms of different reserves working with their partners, thinking about what might that mean in our region. So those are just some of the stories for how we went about that. But in the early days, it was a lot of conversation, one-on-one. That hasn't gone away, a lot through workshops and just kind of using that then to kind of work our way through, okay, so how do we connect the dots to your work and bring this home in your area to make it meaningful? But it's a different message for different folks.
Yeah, I can add one. This is a good list. I think one of the most important things is this concept of reducing methane emissions by restoring tides to tidally restricted wetlands. And that wasn't part of the project in the beginning. Our first stakeholder meeting, similar to this one, although smaller in scale, we had someone from the DER, and we have people from the DER here as well, and part of what they do is restore tidal flows to wetlands. And I don't know about other people in the group, but I was sitting and thinking, okay, that's a salt marsh restoration, but what does that have to do with carbon stocks in soils? And there may be a linkage there, but this methane concept is very clear linkage, and so I think, as Steve said earlier, he kind of was thinking early in the project maybe there aren't that many opportunities in New England for salt marsh restoration in a carbon market context, but now that thinking is reversed.
And Bob, I would say that those two examples that I just ended with are two of great ones to kind of show that two-way interplay between science investigators and end users, kind of having that throughout, making methane connection, which wasn't there before, and that's become full circle as a bigger emphasis. And then this other point of the grouping concept in reality, how do we do that thinking about the scale of projects? So I'm aware of the time that we're actually at 5. It looked like we weren't going to have any questions, but, and Tom is like, don't forget me, I have one. You have one? Okay.
Yes, I think we are missing the most important product.
The model.
for the stakeholder. My message to them that whatever the other folks and scientists just told right now, okay, I boiled all of this down into one Excel tool. So my message is that I have a science-informed tool, not just any tool, a tool developed based on scientific data, and you can use it without being a scientist. Okay, so that's simple and straight.
Cool. So I was going to follow up on some data that Serena presented, and I know that her student also presented some data looking at the different vegetation communities resulting in different greenhouse gas sinks as well as methane emissions, like, for example, Phragmites, and that sort of presents an interesting case study with respect to restoration. And I was wondering, so you have this plant community that may be an amazing greenhouse gas sink, so you may say, okay, let's keep it. At the same time, it emits 4 times more methane, I think is what they presented. I was wondering, how do you go about selling something like that? Sort of maybe even thinking about it for tomorrow as well.
Thanks.
Yeah, unfortunately Serena's not here. Rose, do you want to say anything about it?
So, Tom, I think that's a really interesting question, and that's something that Serena and I have chatted about a lot as we've looked at this data. Seeing that, well, while we don't necessarily have the experimental component at this point to indicate that Phragmites, the plant itself, is responsible for the differences in the two greenhouse gases that we're looking at, that zone, the Phragmites-dominated zone, definitely produces more methane or emits more methane but takes up more CO2. So I think it raises difficult questions for managers, certainly depending on what you're managing for. If you're wanting to store or potentially sequester more carbon, well, maybe leave it alone. But we're actually doing some work in my lab now where we're looking at effects of Phragmites removal and tidal restoration as part of one larger restoration project. And I'm beginning to see the very beginnings of an increase in salinity this season as a result of that tidal restoration. And so I will certainly keep everybody posted on changes to the plant community, and if I see changes to greenhouse gas fluxes, I think that might elucidate responses to that conundrum a little bit better. Thanks.
I think maybe one of the things I would add is, one of the things that restoration is moving towards, and the carbon planning is moving towards, is we want to restore a landscape, and we need to think about landscape processes, and you do the accounting across the landscape in that regard. Where problems run in is where you're trying to develop sort of mono-species cultivations, and all the problems you had in China with bringing in invasive species for forests, non-native species. If we restore a healthy landscape, that's going to be our best outcome, and we do the accounting recognizing that. We could always tweak it and try and make one species in a niche, but it's at the degradation of another ecosystem service. And so I think my argument and what we're trying to push when we're trying to think about these plans is restore a viable landscape, plan for change, and that is what you're going to get out of the greenhouse gas management. Don't try and force it into a box that you have to try and maintain.
Thank you. Well, I wanted to thank everybody for their participation in this last session and the great questions. Thank you, BWM team, and there are people who are part of the team that are not up there that we'll hear from tomorrow. So quick setup for tomorrow, we're talking about these issue focus areas, sea level rise, nitrogen, more on that. We're going to be hearing from some other researchers who are not a part of our BWM team who are doing related work. And we'll also have a chance for those mini sessions that we talked about. And then we're going to talk about policy applications, hearing some examples of that at the federal level. And we'll end the day with a panel discussion hearing from people who are wearing kind of different hats on this subject. What's next for blue carbon as we think about connecting it with our work. So thank you. The posters are set up. Thanks to everyone who brought a poster. And then we also have yummy food also. Thanks, everybody.